Thank you. Hey, everyone.
Hello, everyone. My name is Rafa, and I'm here with Asen.
Hi, guys. Nice to meet you all.
We are both part of the Wasm Labs, which is a team within the VMware Office of the CTO. And our main goal is to make it WebAssembly more visible to developers and to bring more developers into the WebAssembly space. And so we contribute projects and we create projects that showcase what are the possibilities of WebAssembly and how developers can take advantage of it. So why would be the first question on why would I run interpreted languages in WebAssembly? I think we have mentioned this like a few times already during these couple of days, but it's clear, like we have more security, we have the sandboxing, we have capabilities as well. So that only that is interesting in order for people that are using these interpreted languages that are not being able to get out of the sandbox. Also, in terms of portability, the fact that I can get my interpreter along with my program, for example, and get this unit of code that I can, or this binary, I can develop that everywhere. It's also very interesting. And you can also do all kind of things with portability. Because right now, you need the interpreter to be built into different flavors or for the architecture that you're working to work on, or for the operating system that you are going to run your program at. So you still need to do all this kind of combination. With WebAssembly, you don't need to do all of that. And also in terms of size, because it's going to be a smaller, your backpack is much smaller. You don't have a libc, you don't need the whole sysroot of an operating system. So in the end, size, despite with the interpreted languages, is not as small as we would like. It's still very good. And so in the other hand, we have also how we can help people or developers with WebAssembly's adoption. And the idea is that they can reuse the applications that they already have, or at least have most of the applications that they already have and reuse them right away. As well as their frameworks, they don't need to learn new stuff. They just can reuse everything that they have in terms of applications, in terms of frameworks. And in theory, so in the end, all this is about knowledge, so reusing the knowledge that you already have. So you don't need to learn new things if you don't want. And it makes this is also cheaper for companies in the sense that they are able to reuse this knowledge and they are able to reuse what they already have. So that's the why, and the what is we have like different projects within our group. The one that we are talking about today is the WebAssembly language runtimes. What we have released at this time is PHP, Python, and Ruby. We have to say that Python and Ruby has done a tremendous effort in their communities, and so that was really, really easy and straightforward to include in our project. And for PHP, we are working actively in migrating that upstream as well. And so the idea for this project is that it needs to be up to date, and for that we are going to use automation in order to keep everything like to the last minute, let's say. We also want it to be tested, like we need the battery tests of the upstream projects to be executed. Maybe we have to remove certain parts of this unit testing or this testing because in the WAS environment, some things cannot be really mapped. But in theory, what we want is to keep as much as possible all the tests that we can keep from upstream, and also provide tests that are specific to this new platform. So it's also open source, so you can find absolutely everything that we are doing in the open. Everything is in GitHub in our group. You also have examples, so we want to build even more examples. We want to build more documentation on that, on letting people know how they can use these projects and take advantage of these projects, so they can reuse everything they have, and they don't need to dig too much into the details of WebAssembly. Like they just download the interpreter and everything should work, and that's the plug and play part. So you just download the interpreter, everything works, and if something is not working, we should have provided documentation on how you can address this issue, and if not, you can contact us, and we are going to work on seeing what is wrong and how we can help you with that. So apart from that, we also have multiple flavors. So here we have, for example, the PHP CGI binary example. We have the slim version, which is, as you see, 5 megs. This contains not that much on the standard library, so we removed a lot of things on the standard library in this one. We also have the regular one, which is, as you can see, about 13 megs. There are lots of libraries in this one, like even image processing, for example. So all these ones, we have importing them, and we are going to continue doing so. So not everything is migrated, but as we go, the idea is to have multiple flavors. So if you don't need everything that the standard library provides, you are going to be able to use the slim one and use just the part that you need. And also multiple formats. For example, here on the Python example, we have the 11 megs one. This actually contains 2 interpreters because of other reasons. We are going to see that as well. But the idea is that in this one, you have the binary, and you also have the standard library. And you can mount that, or you can map the standard library inside of the WebAssembly runtime, so that Python, the interpreter, can find its standard library, which is written in Python. And then we also have a Wasm module for Python, which is built using WASI-BFS. And so the idea is that all these projects will give you a way to consume them in these different ways. We don't have all the combinations right now, but the idea is that with automation, we're going to be able to do that. And we also have a container that we built for Wasm Edge integration with Docker. And so you can run Docker and Wasm. You can run Python in Docker plus Wasm. And the idea, as I said, is to have automation built for everything. And so we are able to get like early notice of when something has been bumped upstream. For example, here, our PHP master patch is being rebased on top of master every day. And so we have early warnings when we get drift from the original or from the upstream project. And for example, this is Michael Joan. So this is the co-founder of Wasm Edge. And he says a regular Python runtime image takes up to 1 gig. A slim one is 40 meg. An equivalent Docker plus Wasm Python image running on Wasm Edge is less than 7 megs. And so, we see this benefit on users that have interpreted languages today. We also see other combinations, and we also want to invest more and know more about the future of WebAssembly, like what are we going to do with the snapshot tool, how we're going to adapt to that, and in general to move with the community. So the interpreter is just part of the story. As we were telling before, you also have standard libraries. And so we also have to work on porting those. And so this is the ones that we have ported. The idea is basically the same one, up to date, tested, everything automated. And we want them to be reusable. So this is not something that we only consume. We want people to reuse this work and use these static libraries. And we want it to be really easy to add more. So everything is in the open, this as well. And so if there is some library that is not there, that you want to contribute, we are really happy to know about it and to add it. So we are really open to add more, and also to adapt if something is not really working as you expect, and inspect why is that not the case. OK, so with that, let's look at a demo. So here, what we are going to do is to use this last part, which is the libraries that we provide. And besides the list that you have seen, we provide a bundle that contains all of them. And so what I did was just to download this bundle, and I extracted it. And so here, you can see like there is this sysroot that contains the include headers and also the lib, the libraries that are statically compiled. And so we also provide pkg config files. And we are going to see how we can get advantage of that. So if I have set up correctly my pkg config path, then pkg config will be able to find all these libraries. And so in this case, I also set the sysroot dir. So this is where things are going to be related to when I get related headers, when I get related libraries in order to link. So I can run list all from pkg config and see that it actually detects the whole list of all the libraries that we provide at this time. And now what we are going to do is we are going to build a program that uses UUID, the library, to produce UUID references. And so here, for example, with pkgconfig, I can just ask for the UUID. And the cool thing about this is that you get the libraries that you need in order to link the final binary. Because if, for example, you miss the getPID library, then you will get a link error at the end. And so you want everything to be linked at the end. And so that's why we provide these pkgconfig files. So it's easy for you in order to use these libraries. And also, you get everything you need in that case. We have to check why we need the getPID in the UUID library, but this is something that we will talk about later as well. So I built the example, which basically is a main C file that includes the UUID and generates like 3 variants of this program. The first one is CLI tool that just writes a new UUID on the standard output. The second one is a CGI mode, and basically the same, just with the header of the content type. And then the other is Wasm worker server binary that can be used with Wasm worker server, a project that we also develop. So we see the 3 artifacts. I just build them. And I can run the CLI one. And so in this case, I get the UID generated, which is what I was expecting. And then if I run the CGI one, I also get the very same thing, but in CGI mode. And now this one is kind of the contract that we have with Wasm worker server in terms of we don't have like an SDK, or we don't have a way or a library to talk to Wasm worker server from C, because this is a C example. I just wanted to do right away without anything else. And so here, we're basically printing the JSON that Wasm worker server expects in return. So I can run Wasm worker server that's actually running. And so as Wasm worker server, I don't know if you saw that yesterday, but it detects the paths and it detects the artifacts that are there, and it's going to be able to show you like the paths that you can address. And so in this case, if I go here, I get the expected thing, like I get the UID. And oops. Okay, I can do the very same thing with the spin. So I can run it in WAGI mode. And I can put the root and /UUID. And so I can do a spin up over here and just get it there. Oops. OK, this is expected as well. And now we have another project, which is mod Wasm, that is an Apache module where you can run WebAssembly. And so in this case, you can see the configuration. You can address /UUID as the location, and then we are going to enable CGI on this module, CGI mode, and set the handler to the Wasm handler. And so now I can run Apache and address that as well. So in this case, you see like the answer is actually coming from the Apache server. So this is the example. So this is one part. Like I built a very simple binary that uses the libraries. So you can use all these libraries that you need in this very same way. So this is a very easy example in order to find out how to use them. But there are more things. Like, for example, here I have a button generator. And so I did that with PHP because on the one that is not the Sling one, the one that is batteries included, we have the GD library in which we can address changes on images and load images and so on. So this is an image. This is not any kind of text or anything. We are generating that. But this is really like the 90s, right? So we can even get even more into the 90s. Like I'm feeling lucky, and I can change that message, and the image that is generated is that one. So I can even download that one. So this is a PHP script that is generating this output image, and I can just download that if I want. And it's not only about this type of examples, right? So we also made Drupal work, WordPress work in the server side as well. And so you can see that if I go around It works pretty well. Like, it is quite fast, and everything seems to be like fine. And now I can even add a new article, for example, or a basic page. I don't know. Test. Okay, and that works. So the idea is that people will be able to use their PHP applications as they are used to. Of course, this uses SQLite right now, but the idea is that they will be able to use more backends if they want in terms of databases. We're still working on that, but the idea is that this is what we want people to try. This is what we want developers to give us feedback on if there is something that is super important for them that it's missing, we would like to know. And so you can find the project here, but Asen is going to talk more about that. So I will just, oops. Yeah, Asen is going to talk to you more about sister projects and more. So yeah.
Thanks, Rafael. So I got the honor of telling you a little bit more how we are doing what we're doing after the great demo by Rafa, showing how to use it and what it is. But first, a few words about the sister projects that we're working on and how this whole thing fits in our whole view of what's going on. So the first thing is mod Wasm. It's a little bit weird, I guess, to focus on stuff like Apache that's considered legacy even and old. But let's face it, like everything we're doing today gets paid by all the thousands and thousands of deployments of legacy apps out there. And there is a lot of code running out there. And we think this is a great way to port that to Wasm. So by providing language runtimes and integrating them in a way with Apache, you can get a legacy application just as Rafa showed us with Drupal and run it out of the box on Wasm, thus like expanding the range of developers and also helping us fix like edge cases in the standardization, things we didn't think about that are already out there with legacy applications, and we will need several years to get in all of those edge cases as we write new code. The other thing is the Wasm Worker server. You already know about that, I guess. Yesterday, there was a wonderful demo of that. So whatever we do with language runtimes can be reused in both of these projects easily, just the same binary. And now about our process or how we approach this case. So we're following a simple strategy. Make it work, make it right, and make it fast. So the first thing is to get a Wasm 32 WASI build. Sometimes it's pretty easy. With some libraries, it was like running make and it works. Other times, it's like a lot of debugging. We need to patch stuff. We need to test with some basic examples. It may take a lot of time. So the main idea of Wasm language runtimes is to save everybody that time. Once we have done that, you can reuse the binaries, all the build scripts and patches. Everything is in a repository, so you can build on that. The second stage, making it right, involves tracking the upstream source code of that project, contributing there, as Rafa said, with PHP, trying to run more advanced apps. So for example, the Drupal app that you saw, until we got it to run, it had a lot of time, a lot of experiments to fix like the tiny little edge cases and make it run all right. Adding more test suites so that the things that you can do are stable and everything's production ready. And like the last part, improving and making it fast, adding more functionality, testing, optimizing. It comes naturally once you have something stable that works. So we are trying to follow this process like for everything we do. Each interpreter, each library, it's nothing strict, but what I'm mentioning is that you'll see a release, you'll see a binary. There may be like edge cases in which it doesn't work. That's because it's still not in the last stage. We'll be very happy for any feedback, any comments on why and what's not working. And of course, we are trying to work in a huge community with huge support. Kudos to WASI SDK, WASI libc, and LLVM because everything we do is based on their work, huge work. Also, Binary and Wabbit. We use the first tools to get a Wasm build, and the second ones for optimizing, debugging, and stuff. Huge help. Also, as Rafa mentioned, there's a lot of work done by others before us. Like the Zero-B team did a great job providing a full Wasm 32 WASI support for Zero-B. And in the process, they developed two very good tools, WASI VFS and Asyncify, like a code base that uses Asyncify to provide stack switching that allows exception handling and fiber support in Ruby. We have stepped on those, for example, using WASI VFS for Python or not yet for PHP, for Python to package applications, and the code on how to use that and link to that is still in the repository. With Singify, we have experimented using that with PHP. It's not yet out. We'll have to see if we're going to use that or wait for the stack switching proposal. Then come the CPython guys who also did a great work and are constantly supporting any questions, anything related to WASI, very enthusiastic. And of course, the single store labs team who stay behind many of the things behind CPython, and especially some of the static libraries, which were ported to WASI. We reused a lot of those in the beginning. Now we're rebuilding them on their own. Also, the single store labs guys are working to enable to enable Python modules with dynamic linking and a way to build that. We're probably going to reuse some of the path that they have paved. And of course, except for using work by others, we also try to contribute as much as we can upstream. So one funny story is with the SQLite team. So we stepped on patches by many other people, like 4 or 5 list of historical changes and people trying to port that to WASI. We did a little bit of tweaking on our own, and then we contacted the SQLite team, and they were very friendly, and we worked together so that they could embed this in their source code. And as of this version, you can build for WASI with SQLite. You just need the WASI SDK, and it works. And then, of course, the PHP thing. This is the PR. You can track it if you're interested when PHP is getting native support for WASI in their main source base. It's, as you can imagine, a long process. Also, we try to experiment and build stuff together with other players in the ecosystem. One of the first guys we tried doing something with was Wasm. Using their socket support, we ported that to PHP 7 point something, and it was really cool. It did work. We managed to get a server written in PHP, listening to ports, very helpful. Another thing was the Docker plus Wasm beta announcement. We were very glad to test that, to make it work, to report on issues and stuff. Super responsive people. So yeah, that helped us improve a lot. And naturally, Suborbital. We were recently working with them on Python to host and host to Python communication. So you can check this out. They already published the blog post, and one is coming up on our site in I think next week sometime. And most importantly, anybody who wants to collaborate on this or has some great ideas and want to do something with us, ping us there at Twitter or contact us on our website. We'll be very happy to work with you guys on any great ideas. We're in the process of working with other projects right now, but nothing's yet complete, so I'm skipping that. Now, always the great question, what's next? So, as I told you, the process of making it work, making it right, making it fast, most of the work has been on making it work. Now we're moving toward making things right. So, right and fast, it's what's going to happen. And the way we're going to do that is by adding more functionality and trying to optimize stuff. And adding more functionality usually happens by testing with more and more legacy applications, with more and more legacy use cases, because the great benefit of running interpreted language runtimes is that you already have a lot of legacy code which you can use to test the WebAssembly runtime, to test the approach, the performance, and everything. So another thing is the easier artifact customization. So there is this thing about WebAssembly. You cannot do deal open, or rather, you cannot reuse dynamic modules yet. So you need to build static libraries, combine them into the same library, and the whole thing happens during the build process. Everything is in the build scripts in the repository. So if you want to do something on your own, check out the repository, try it out. Everything is there, packaging different versions of PHP with different extensions and stuff. But we want to work on making this more user-friendly, so that the end developer, who is our target customer, so to say, can use this out of the box and move to WebAssembly without second thought. Of course, it also means we need more examples and making stuff easier for contributors. And naturally, with time, we need more runtimes and more libraries as need comes be Like, here are a few examples. For example, the Python community is crazy about NumPy, scikit, and stuff like that. So we're probably going to focus on that. Naturally, QuickJS is coming up sooner or later. And as we're speaking about legacy code and stuff, I don't know how many of you will recognize the logo at the bottom. That's Tickle. So if there is interest in that, and anybody wants to help with that thing, we'll be super glad to work with you. Now, here are a little bit of examples on how you can try out the language runtimes and what you can do with that. All of those are at the URL at the top. That's the root README of the repository, so you can find them out with references to articles or pages where they suggest how to do it. Most of them don't require much time and don't have like huge technical requirements. Rafa already showed you WordPress in Wasm. You have seen how to run workers on a Wasm worker server. Like, interestingly, you can run the php.wasm thing with Spin and Fermion Cloud. There is a great article about that. Also, you can use the Python Wasm container with Docker. It's pretty easy, just using Docker. I guess everybody here knows how to do that. Then, if you're more into C applications and porting legacy code, you could try using one of the static libraries. We have an example of that. Rafa already showed that. And I didn't put it here because the estimated time was like from 1 day to 2 weeks or 1 month. You could try porting a static library, like a legacy static library, like, I don't know, let's say OpenSSL. That's going to be a huge project. You can try porting it to WASI. We have like the build scripts, the infrastructure, like everything, which will make it very easy for you to get started, like the whole process. So yeah, give it a try and ping us if you need anything. I guess that's it.
Okay, so there is one question over there.
Hello, thanks for the talk. Is Node on your radar?
We haven't looked into that yet, but I mean.
Yeah. So mostly we're trying to listen to the community. So if everybody here says we want Node, we'll probably consider it a lot. Like, we're hoping that everybody will say we want Tickle, but yeah. So definitely there is interest.
Yeah. Just open an issue. I mean, if you're interested, you can open an issue and we can open the conversation there. So. Yeah.
Thanks for the talk. I have 2 questions. The first one's serious, the first one is not. Or the second one, rather. First question, have you tried to run Python with NumPy and OpenCV or a Jupyter Notebook or anything like that?
Not yet, because we cannot yet compile NumPy. So the thing is that with NumPy, there is a C extension code, and the C extension code needs to be compiled to WASI 2. And for this thing to work, you need to compile it as a static library, and then have the interpreter as a second static library, link both of them into like one major binary, and then combine it with the Python code. So as a matter of fact, I think like last week or a week before that, a guy from Signal Store Labs managed to do that. It's on a thread in the Python discussion forum. And he said that he's going to like document the process once it's all clean. But it's doable, and it's working. Like, he posted a demo, which is great. So eventually, that's going to happen, definitely.
My second question, so are you trying to say you can run Rails, Drupal, and Django at the same time in a single WebAssembly application?
In a single no, not in a single WebAssembly application.
No, I'm throwing the mic away.
Yeah, eventually, you will be able to. I mean, we haven't tried that, but why not? That's the idea. That's one. Yeah. Okay. Yeah. All right. So I guess that's it.
Yeah.
Yeah.
Thank you.
Thank you, guys.